Okay, hello dear friends. Let's do a math problem. We need to draw, it's a trigonometry, y equals 3 plus 2 sine 2 theta minus 10 degree. Okay, there are a lot of things. So last night when I see this problem, I was just immediately, I got so blacked out. And I could not process this. And then I start to think, and slowly my conscious regain, and I can do this problem. So it's a trigonometric function. We need to draw a graph, a trigonometric graph, and it's about transformation. Extension, a starting point move, weight move of graph. So to begin with, we draw a basic form. For this kind of problem, we know trigonometric function or graph are continuous and there is no end. It's one rotation, two rotation, keep on doing it, and we will not draw too many. We will draw just within 2 pi. Okay, here 1, 2, 3, 4, 5, 6. 1, 2, 3. Can you see it? Maybe I need to make it darker here. Okay. 1, 2, 3, 4, 4, 5. -1, -2. 1 pi, 2 pi. Okay, because the -3 we do not need. I will show you why we do not need. 1 sine, the basic form, 1 rotation is 2 pi. So we start by writing down how we transform it. The most basic form is from y equal to sine theta, right? So this is theta, this is y value. We already know the sine theta, the y equal to sine theta, the sine rotation is starting from 0 when y equal to half pi and 3 pi over 2. When theta is half pi, it is 1 pi 0, 1 and half pi -1. So this is the basic form. This is where it starts. It's all start from here. This is the beginning to the end. So this is our very first function graph. This is graph 1, y equal to sine x. Now we need to do the second one, y equal to 2 sine x. The first step, go 1 step at a time, 1 step at a time. There are many people that they can see 10 steps, 2 steps, the 10 steps ahead of their life. I am not, so I will do it slowly. Y equal 2 sine x. Y equal to 2 sine x, the constant, the coefficient is 2. It means the previous value, you need to time 2. So when 1 is 1, 0 is 0. When the previous value y is 1, now the new 2 times become here, 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 here. So this is the second graph. Okay, I will use another color, which is blue. Okay, we finished the very first transition. Now we do the second step of transition, y equal to 3 plus sine theta, which means it moves the graph 3 steps up, right? And this one, when y equal to 0, here y equal 2 sine theta, y equal to 3 up to 0. So when y equal to 0 now becomes 3. When y equal to 2, it becomes 5. Pi 0 negative 1. Okay, now this is the new function. This is the function, this is the graph 3. Graph 3, now we change another color. Brown color. Did we have brown? We don't have. Perfect. So this is this. This is graph number 3, which is y equals 3 plus 2 sine theta. Now we do the graph number 4. Graph number 4, y equals 3 plus 2 sine 2 theta. 2 theta. When we have 2 theta, it means the frequency is at the previous 1 rotation. Now need to have 2 rotations. If this one is 3, if the coefficient of the theta is 3, then it means 3 rotation when previous was 1 rotation. So we need to shrink it. Within this strand, there will be up and down, right? Negative 1. What color do we use? Let's see our luck. Who knows what color will pop up? Blue? No. We have blue. Blue is not. Chocolate? No. We have chocolate. I'm a little bit confused with this color. Okay. So pink. This is our fourth graph. This is y equal 2 sine 2 theta. Now we come to the last step, number 5. Y equal 3 plus 2 sine 2 theta minus 10 degree. Okay, here we use radian. And come out of nowhere, there is a degree. Get out of this degree. You get out. Okay? 10 degree in proportion with how many radian equal to 180 degree is 1 pi. Right? Degree, get out. So x equal pi over 18. Pi over 18 is just a very, very small value. Pi over 18. This is half pi. This is fourth pi, eighth pi, around here, around here. Okay. So it's minus 10 degree. It means it delays. It delays. So it shifts to the right. It delays. Yeah. When it is already when here theta is 0, here is negative 10 degree. So so it delays. Come here, 2 degree. Exactly the same thing. 10 degree. The shape and everything is still the same. It delays 10 degree. Now we will do this one. Okay, what color do we get? Orange. Orange. No, we will not use orange. We will use the finishing one is this most significant one. Do I explain? So it delays. Okay, so this is our finished graph. Looks a little bit after all this this working, it becomes relatively more understandable. I hope. I love you. I really do. Do. So this is why I like to do math. I am not good at math, and it takes me very much a lot of time to process all this information, and it is a hard work, so I need to fully concentrate and do not think about anything. If I am doing something else, if I do not have anything to do, I browse internet, I waste time, and the mostly is that I start to think about something miserable things. Oh, I haven't finished this job, I haven't, and my family had this problem, and the world has this problem. I start to think about this. No, if what do I say? If I do math, I will not think about this. I will if I do math, I need to put my heart and soul completely into this. This is very logical and gradual and step by step. It makes me feel good to clear my mind from all this chaos, from all these problems, from the outside, any problem, political problem, world problem, and anything else. Because at the end of the day, I know my ability. I cannot change too much. It's important that I keep myself sane and keep myself in the right mindset. And doing mathematics, doing painting, cleaning up my house, doing dish, cooking, and have my hand occupied in things, especially cutting vegetables, have my hand occupied in doing something, and undistractable, because if I got distracted, I will cut my finger out and something. And if I wash my dish and not taking care of it, it will waste too much water and make my glove wet or something. Make sure I do things, occupy my mind. That's the reason. I love you, I really do. I hope you have a wonderful, 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 for everything. Bye-bye, friends.